Now that we know how to divide by a monomial, let's talk about how we divide by a binomial. And we're going to start off with the very simplest sort of binomial, namely a linear binomial. So we'll have an x and a number as the terms of our binomial. For our first example, let's divide this polynomial by the binomial x minus 2. Again, the question we want to answer is, what do we need to multiply x minus 2 by in order to get this polynomial? Let's start by thinking about when we do polynomial multiplication, how can we get this leading term, our 8x to the fourth? Well, the only way we'll get an x to the fourth term is if we multiply some x to the third term by our x term. And that's the only thing that's going to give us an x to the fourth term. We won't have anything higher degree in our quotient because that would give us something in our dividend higher degree than x to the fourth. And there's no time when multiplying anything of degree 3 or lower by my 2 is going to give me an x to the fourth term. So x times this term of my quotient has to give me x to the fourth by itself. That means this term of my quotient has to be 8x cubed. Right? This is the only x to the fourth term in my product. But now I know what has to be here when I do my multiplication. I'll have to have 8x cubed times negative 2, so negative 16x cubed. I think I want to have an x squared term over here. In fact, I think my quotient is just going to have an x cubed term, an x squared term, an x term, and a constant term, and then probably some sort of remainder, which means this diagonal is going to have all of my x cubed terms. This diagonal is going to have all my x squareds. This diagonal is going to have all my x's. This diagonal is going to have a constant. Oh, and my remainder has to be lower degree than this. So my remainder will be just a constant also. My x cubed term has to be negative 16x cubed plus whatever this is. And it needs to add up to negative 3x cubed. Negative 16x cubed plus what gives me negative 3x cubed? It must be positive 13x cubed. Oh, but then I know what number has to go here, because x times whatever this is has to be positive 13x cubed. So this has to be positive 13x squared. Multiplying 13 times negative 2, I'll have negative 26x squared here. Negative 26 plus whatever this is has to be positive 5x. So negative 26 plus what is positive 5? This must be 5 plus 26 is 31. This must be 31x squared, which leaves this no choice but to be plus 31x. Ooh, big numbers. Yeah, this happens. 31 times negative 2 is negative 62x. And now again, my negative 62x plus whatever goes here has to give me negative 4x. What goes here is going to have to be negative 4 plus 62, so 58. I'll need a 58x here, which means I need the number 58 up here. 58 times negative 2, this looks like a job for a calculator. 58 times negative 2 is negative 116. Negative 116 plus my remainder is going to give me 1. My remainder is going to have to be 1 plus 116, so 117. What's my answer then? My answer is 8x cubed plus 13x squared plus 31x plus 58 with a remainder 117. Now, I should mention that there is another way to write this out, which looks like long division of whole numbers. If you are familiar with that method, please feel free to go ahead and use it. I like this method much better because it's much easier to keep track of the signs of our terms as we work. I'm going to give you one of these to try. If you are not familiar with that other method, please work this way. If you are comfortable with that other method, you may use it. Let's go into a little bit of detail about what we're doing in this method first, though. First, write the divisor on the side of the kind of box we use for multiplication. Put the leading term of the dividend, that is, the polynomial we're dividing, in the upper left corner of the box, as we did 8x to the 4th here. Label the columns by powers of x, and our goal is going to be to figure out what the coefficients of all these powers of x are going to be. Now find the coefficients, filling in boxes as you go. Finding the coefficients really is the crux of this method. In fact, this method is called undetermined coefficients. You know what the quotient is going to look like. It's going to have a bunch of powers of x. You just don't know what their coefficients are. Let's see another example of this, and then I'll give you one to try on your own. Let's do the division 2x to the 4th minus 3x cubed minus 30x squared minus 7x minus 6 divided by x minus 3. So I'll have x minus 3. And then my quotient, well, it's not going to have an x to the 4th term. It's going to have an x cubed term, an x squared term, an x term, a constant, and maybe a remainder. Here I'm going to have my 2x to the 4th, and then some x cubeds, some x squareds, some x's, and some constants. All right, x times what? X cubed gives me 2x to the 4th? Well, it's going to have to be 2x cubed. Then I'll have 2x cubed times negative 3. That'll be negative 6x cubed. I want my x cubed term to end up as positive 3x cubed. Negative 6 plus what gives me 3? What is 3 plus 6 is 9. So I'll have 9x cubed here. What will I need to multiply my x by to get 9x cubed? It's going to have to be 9x squared. 9x squared times negative 3 is negative 27x squared. I'm going to need to have negative 30x squared altogether Negative 27 plus what gives me negative 30? Well, what is negative 30 plus 27? So negative 3. I'll need negative 3x squared up here. What will I need to multiply x by to get negative 3x squared? I need to multiply it by negative 3x. Negative 3x times negative 3 will be 9x. I ultimately want to get negative 7x. So 9 plus what will give me my negative 7? Well, what is negative 7 minus 9? Negative 7 minus 9 is negative 16. I'll need a negative 16x up here. Well, that means I'll need a negative 16 here, right? X times negative 16 is what I need to get negative 16x. Down here I'll have negative 3 times negative 16 is positive 48. What will my remainder be? Well, 48 plus what gives me negative 6? What is negative 6 minus 48? I think that's going to be negative 54. What do I get for my answer? I get 2x cubed plus 9x squared minus 3x minus 16, remainder negative 54. I'm going to give you one of these to try now. Work this division problem. Pause the video and try this now. Alright, so how shall we set this up? We'll have our 2x plus 1 down the side. We'll have our 2x cubed in the upper left, which means in our quotient we'll have an x squared term, an x term, a constant term, and possibly a remainder. If you were stuck on getting this set up, pause the video and try to finish the problem now. Again, remember we expect to see x squared down this diagonal, x down this diagonal, and constants down this diagonal. So 2x times what will give me 2x cubed? 2x times 1x squared will give me 2x cubed. So here I just have x squared times 1, which is just x squared. Remember, I need to get negative 5x squared as the total down this diagonal. So I need 1 plus what is negative 5. What is negative 5 minus 1? It's negative 6. So I need negative 6x squared here. 2x times what will give me negative 6x squared? 2 times negative 3 is negative 6. So I need negative 3x here. Negative 3x times 1 will be negative 3x. I need to get positive 7x on this diagonal. So negative 3 plus what is 7? What is 7 plus 3? It's 10. I'll need 10x up here. 2x times what will give me 10x? 2x times 5 will give me 10x. Positive 5. 5 times 1 is 5. Down this last diagonal, I need to get positive 10. 5 plus what is 10? Well, 5 plus 5 is 10. Right, 10 minus 5. So my remainder will be just 5. My answer then, I have x squared, I don't need to write in the coefficient 1, minus 3x plus 5, remainder 5.